Hello, good morning, students. Welcome back to the last videos of this chapter, that is combustions and flam. In the last videos, we have discussed about different types of combustion, disadvantages of incomplete combustions, their ignition temperatures, and what are the conditions required for the combustion source. So, here in this video, we will discuss the last topic, that is what we call flam. Okay, in this topic we will discuss the last topic, that is what we call as a flam. Okay, let's move into it. You see, what is a flam? Now you see, you might have seen when the when you light up a matchstick, so you burn a yellow flame, right? Or similarly, if you burn with a candle, you see, you might have seen this thing. This is what we call as a flame. What is actually the flame? Is it? A flame is a zone of combustion of combustible substance. Okay, it is a zone where combustion. Okay, where it is a zone where the combustions of the combustible materials take place. Okay, or a regions of the burning gases is called as a flame, or a regions of the burning flame, or a regions of the burning gases is called a flame. Okay, it is understandable that LPG gases, therefore, a region which burn constitute a flame. However, wax solids. Okay, how can a solid produce a flame? Okay, so you might have seen this thing. You see, a substance which vaporizes during the burning produces a flame. Okay, the substance which will vaporize, they will vaporize during the burning, will produce a flame, like your candles. Okay, like your candle, they produce a flame. Like you see the kerosene lamp. Okay, they will produce a flame. But the substance which do not vaporize during the burning does not produce a flame. You see, this is what you can see out here. Okay, this is what you can see out here. Okay, this is a coal burning, the charcoal burning. So whenever it has been heated, that means they don't produce a flame. Okay, so this is what we call as a flame. Okay, so whenever there is a evaporation take place, you have to know that, and the flame is produced. This flame is produced. Okay, so here let's study about the structures of the candle flame. You see, in your textbook you have been written as a blue zone, dark inner zones, or luminous zone, or non-luminous zone. It is same things. Okay, so we'll just make it very clear, and we'll just try to know it in this three-man zone only. Okay, three-man zone. In the candles, it has been divided into three-man zone. The three-man zones. Okay, the flame does divided into three-man zone. The first zone is called as outer zone, and second zone is called a middle zone, and the third is called as the inner zone. This is the outermost zone, which is also called as the complete combustion take place. Okay, or also known as a blue zone. Okay, here complete combustion is the outermost. Okay, so this zone is known as a this zone is complete combustion, where the complete combustion take place, is known as a blue zone. You see, in the outer zone, complete combustions of the fuel take place, and the colors of the flame is blue, and is the hottest part of the flame. It is not the luminous part of the part. It is non-luminous part of the flame. Okay, so what is it in this zone? In this zone, you will see this is the outermost. If you can see in the candle, you will see a part of blue parts. Okay, so this part is what we call as outer zone, and here the complete combustion take place. Okay, that means here the fuel get completely burned up. Here the fuel get completely used up. Okay, so you see, this is the hottest, and it is the hottest. This is another. It is the hottest part of the flame. The outermost. It is the hottest part of the flame. Next, you see, in the middle zone of the partial combustions of the fuel take place. The color of the flame is yellow, and is moderate hot part of the flame. It is the luminous part of the flame. Now you see. You might have seen this part, yellowish colors, right? This is what we call the middle zone. Is what we call as a yellowish part, and this yellowish part is here the partial combustion take place. Okay, not all the the fuel is not completely burned up. Okay, that is why they produce a yellow color. Okay, and they also produces some they also the moderate hot part, they produces a very light, it is not too hot, so it's not too it's that they produces a moderate hot. Okay, next we have a last zone, that is called the inner zone. There are unburned vapors of the fuel, and the color is black, and is is the least hot part. Okay, you see, you might have seen this part. Okay, this part where this is what we call the inner zone. Okay, we are unburned vapors of the fuels. Okay, there the fuel does not burn. Okay, the fuel does not burn, and the color is black in this case. Okay, so it is not a hottest part. It is not a hot part. Okay. You see, and the luminous part is what in this zone, a partial luminous of the combustions vapor take place with the liberations of lot of heat energy. The energy is so liberated partially decompose the wax vapor into the carbon particles. Okay, the carbon particle turn get very hot and emit yellowish blood. And luminous zone of the candle flame is hotter than the dark inner zone. Okay, the luminous part is what it is a part where it is the hottest part. It is a hotter flame. It is a hotter part, or it is the hottest part, but it is as compared to the dark inner zone. Okay. So these are the structures of flame where we have a three zone. The first zone is known as the outer zone. The second zone is called as the middle zone, and the third is known as the inner zone. The first zone, outer zone, is what the outer zone produces. Where like they produce a blue flame, complete combustion take place. You have to remember this point only. The outer zone produces a blue flame, complete combustion take place. Okay, complete combustion take place. And another thing is what? They are the hottest part. Okay, this is non-luminous part. They are non-luminous part. Okay, but in the middle zone, what is it? In the middle zone, okay, a partial combustion take place. Partial combustion take place. The color of the flame will be yellow. Okay, the color of the flame will be yellow, and it will be a moderate hot part. These are three things. Okay, this is the luminous part of the flame, and it is a luminous part of the flame. The inner zone is one where unburned. It is the unburned vapor of the fuel. Okay, there are unburned vapors are there. Okay, of the fuel, and the color is black. Okay, and it is least hot. So this is the outer zone. Produces complete combustions, produces a blue flame. Okay, and non-luminous part and hottest part of the flame. Second, middle zone, partial combustions. Okay, the not complete combustion is taking place. Okay, second is what produces with the yellow flame. Okay, moderate hot parts are there, and it is a luminous part. Next is what inner zone. What is it? They produce unburned vapors are present. Okay, unburned vapor of the fuels are present. The color will be black, and it will be least hot. Now you see types of the fuel. Types of the fuel here. Fuels are three main types. Fuels are of three main types. The first fuel is called as a solid fuel, and second one is called as a liquid fuel. The first one is called as a solid fuel, liquid fuel, and gaseous fuel. Okay. So solid fuel you see, you might have seen your firewood, your charcoals, okay, coals, etc. are known as solid fuels. Okay, you know very well about this. What is a solid fuel? Okay, the fuels are of two types. Okay, three types. That is what wood, coal, charcoal, etc. Okay, the liquid fuel. What is it? Kerosene, petrol, diesel, etc. are the petrol, diesel, etc. are the liquid fuel. Gaseous fuel, what CNG, compressed natural gas, LPG, liquefied petroleum gas, biogas, and hydrogen, etc. are. This is what they call as a liquefied. This is what they call as a gaseous fuel, and this is what they call as a liquid fuel. This is your kerosene, and this is your petrol, and this is your firewood here, and this is your charcoal here. So these are some types of fuel. Now, what is a fuel? Okay, what is a fuel? You see, any substance which is easily available and burn in air at a moderate rate, producing a large amounts of energy without leaving behind any undesirable residues, is called as a fuel. What is a fuel? A fuel is those substances. Okay, a fuel is those substances burned in air at moderate rates. Okay, and produce large amounts of heat and without leaving any residues. So that is what we call as a fuel. Okay, what is a fuel? A fuel is a substances which burn. Okay, which burn in air at a moderate rate and produces a large amounts of energy. Okay, that produces a large amounts of heat energy without leaving any undesirable residues, is called fuel. Okay, so now we have studied the types of the fuel also. We have studied about the types of the fuel also. We'll discuss about the characteristics of the fuel. Okay, what are the characteristics of the to produce a good fuel? What are the characteristics of the fuel should be there? Characteristics of a good fuel is what? The first characteristic, the main characteristics of the good fuel are it should be really relatively available. Okay, the first thing is what the first thing is that it should be available here and there. Okay, if it is to be good fuel, that means it should be available everywhere. Okay, second, it should be cheap. Okay, it should be very cheap. Okay, second, cheap means it should be like if you buy the coal, if you're buying the petroleum or and natural gas, out of this your coals, oils and natural gas, if this natural gas is costing only 10 rupees and this one is costing 50 rupees and this one is costing 100 rupees, then we will seek for this one because it is more affordable for us. Okay, and it's more affordable for us. So in order to afford, so that means it should be very cheap. Okay, that is what we call as a gear fuel. But if the price is too high, that means we won't be able to buy it, then we cannot consider them as a good fuel, right? So that is what we say. The first thing is what, even though the price is cheap, but it should be available everywhere. Okay, if the this natural gas is not available, that means ultimately we are going to go for the oil. Okay, so that is what we call as a good fuel. So it's relatively available, it's cheap, it should be very cheap. Okay, it should be very cheap, and it's easy to store and transport. It should be very easy to store and transport. It should be very easy to store and transport. Okay, second is what, burn in moderate rate. That means easily they can be burned. Okay, second is what, produce a large amounts of heat. Okay, does not leave behind any undesirable substances, does not cause any pollution. Okay, so what is it? These are some what is it, good qualities. Okay, second good qualities, again we can say, okay, they should have a large calorific values. Okay, and produces a less residues. Okay, that's, yes, I told you, does not cause pollution. Okay, so these are some good characteristics if the fuels are available, but if the fuels are available but they are in a very high rate, that means it will be very impossible for the public to buy. That means it is not a good fuel. Now if the fuels are available but cannot store or cannot transport, cannot reach to your home, okay, that means it become useless. Okay, now burn at the moderate, you have burned the fuel but you cannot burn them very easily. It doesn't burn, that means the problem is giving up. Okay, so that is what again it become a bad fuel again for us. Okay, now produces a large amount of, you're burning the fuels what you have bought as a good, what you have considered as a good fuel, but they don't produces a heat. That means it become again if there causes a lot of pollution. Like you see, when you talk about your LPG and a firewood, which one you consider as them to you consider them to be good fuel? Obviously LPG consider them to be a good fuel. Obviously LPG will consider them to be a good fuel. Why? Because LPG produce can be transport very easily, and it can be transport very easily, right? And it is also available in a very cheap. Okay, can be transported very easily and also available very cheap. And they also produces with a they also produces very high amounts of heat. Okay, and another thing is what, LPG, they burn at a moderate rate. They burn at a moderate rates. Okay, and does not cause any pollution, does not produce any pollution like airs or any carbon monoxides or whatever it is. Okay, but when you talk about the firewoods, okay, it is it's very difficult to transport. It's very difficult to transport from one place to another. Okay, now when you talk about the firewood, the cost of firewood is too large, too high. Yes or no? Now another thing is that it is very hard to transport from one place to another, and sometimes it is unavailable. Sometimes it is unavailable. Now whenever you burn them, they don't produce much amounts of heat, but instead, okay, they produce a lot of smoke, that they produce a lot of air pollutions. Okay, so that is what we can say, the natural gas, LPGs or CNC is much better than the firewoods. Okay, second is what you see. Now we are going to discuss our next is the calorific values. Okay, what is the calorific values? You see, the calorific values of the fuel is the amount of heat energy produced on a complete combustion of 1 kg of fuel. If you are burning 1 kg of fuel, how much energy does it produce? Okay, how much amounts of energy does it produce? That is what we call as a calorific value. And these calorific values are mostly the calorific values of when a fuel is expressed mostly in a kilojoule per second. Okay, how much energy does your fuel produce while burning 1 kg of fuel only. Okay, if 1 kg of fuels are burned, okay, if 1 kg of fuels are burned, and in 1 kg of fuel, how much energy does they produce? That is what we call as the calorific values of fuel. Okay, and these calorific values of the fuels are mostly defined in the kilojoule per kg, kilojoule per kg. The fuel which produces more energy, the fuel which produces more energies, okay, the fuel which will produce more heat energy will consider as a high calorific values. Okay, if your fuel produces more heat energy, okay, per kg, if you say you are carrying firewoods and you are carrying natural gas, but out of this natural gas produces more calorific values than your firewood. That means what? The natural gas have high calorific values. You see, some of the calorific values in the kilojoule per second are given here. You see, cow dung will produce only 6,000 to 8,000 kg kilojoule per kg. Okay, in 1 kg they will only produce 6,000 to 8,000 kilojoule only. Wood 17,000 to 22,000. Okay, coal 25,000 to 33,000. Petrol 45,000. That means you see, the petrol will produce more heat. Okay, kerosene 45,000. They will produce more heat again than all those cow dungs, wood and coal. Now diesel they produce 45,000. So what is it? That means what? This petrol. Okay, now if we talk about again like methane, butane, like LPG, CNG, again the calorific value will be more. Okay, it is given in your tables also. 7.5, the calorific values of gases, liquid and solids are given in a different ways. Okay, so that means what? The if we consider, if we see about the calorific values of the fuels, and if we compare with a solid, liquid and gaseous fuel, then we we can consider that the gaseous fuels, okay, gaseous fuels are the best fuels. Okay, gaseous fuel are the best fuel. Why? Because gaseous fuel can be supplied to the consumers, okay, to customers very easily through a pipelines or a gas cylinders. Okay, now another thing is the gaseous fuel does not leave any ashes or any solid residues on combustion. Whenever they burn, they don't leave behind like charcoals or whatever it is. Okay, they don't leave any residues. Okay, next is what the gases will produce least amounts of harmful gases. They produce the least amounts of carbon monoxide, carbon dioxide. Okay, so this is another benefit. Second is that gaseous fuel can be easily ignited, especially designed burner with a tiny sparks. Okay, they can easily be ignited, they can easily be burned. Okay, third thing is what? They have a high calorific values. That is the most important thing as compared to liquid and solids. Okay, the second last thing is what? The rate of burnings of the gaseous fuel can be easily controlled with the help of control valves. Okay, if the burning is there, if too much burning is there, that means there one like controller is there. That is what we call valve. Okay, control valve. By this we can control the burnings of the rate of the burnings of the fuels. Okay, so these are some important part of the fuel. Now let's talk about the last topics of this chapter, that is called harmful effect of the environment due to burning of fuel. Okay, what happens when we are burning the fuel? Okay, like fuel like coal, petroleum, wood releases unburned carbon particle, which causes respiratory disease like asthma. Okay, so whenever you are burning the fuel like coal, petroleums, or coal, petroleum, yes, and woods, okay, they produces lot of unburned gases, and that unburned gases are what we call as which will causes lot of respiratory diseases. Okay, incomplete combustions of fuel releases, they will release carbon monoxide, which is very poisonous gas, which can cause the disease again. Okay, so if incomplete combustions are taking place, that means they will produce a gases called carbon monoxide, and this carbon monoxide is one of the poisonous gas, okay, which can cause, even if lot of carbon monoxides are present in our environment, that means it may cause to death also. The burnings of fuel releases carbon dioxide gases which rise in the temperature at the atmosphere. Okay, so if you're burning more fuel, okay, if you're burning more fuel, and most of the fuel will release a carbon dioxide, and this carbon dioxide is known as a greenhouse gases. And because of this greenhouse gases, there is a global warming. Okay, the temperature rises. Okay, and this temperature, which causes in rising the temperature of the atmosphere, and this is what we call as a global warming. It causes a melting of polarized rise in the sea wells and a flooding of coastal areas. Okay, so if carbon monoxide more excessive carbon dioxide is released, that means what? If excessive carbon dioxide is released, that means what? More like global warming there will be there. If more global warming is there, that means what? Yeah, meltings of all those polar ice and your sea level will rise, and a lot of flood will be there. So, okay, so this is some harmful effect to the environment. Second is what? Burnings of coals and petroleum release oxide of sulfur and nitrogen which dissolve in the rain and form an acid. It is harmful for the crops, soils, and damaged building. You see, whenever you are burning the coals or petroleum, they releases a sulfur and nitrogen gas. Okay, and this sulfurs and nitrogen gas, when they rise up, okay, they mix up with the rainwaters. Okay, and they come back in the form of acid rain. And if there is more acid rain, that means your crop, your soil, okay, and all will get damaged. Okay, so these are some like harmful effect. Okay, the first thing is what? If you burn a lot of fuels, okay, chances is there a lot of respiratory diseases will be there. Second is what? Incomplete combustion take place means carbon monoxide gases will produce. If carbon monoxide gases is producing, that means what? It is a lot of one of the most poisonous gas again. Okay, that is may cause death. Second, last is what? Most of the carbon dioxide, if the most carbon dioxide are produced by the fuel, and if more carbon dioxide is fuel, and this carbon dioxide gases is what we call as a greenhouse gases, and these greenhouse gases, okay, will lead to the rising like what is that? Will lead to rise in global warming. And this global, if the temperature rises, that means what? Polarized, the melting of polar ice. If the meltings of polar ice occur, that means that your sea level will increase. Okay, if the sea level increases, that means chances is that there will be floods. Okay, next is what? The last topic is what? If coals and petroleums are burning, so okay, if continuous coals and petroleums are burning, that means what? They will produce a lot of sulfur and nitrogen, and this will dissolve in the waters. Okay, and when they dissolve in the water, they will come back in the form of acid rain, which is harmful for our crop, our soils, and even for our buildings also. Okay, so these are all about the topics. Okay, I believe that you are clear about all this topic and go through this. Okay, so go through all this topic and we'll discuss the remaining topic in the next video lectures. Okay, thank you.